It's been a fun project so far. Well, we have our 8008 replica computer built, put together, all the parts, either in my parts cache or got them online, and during the debugging process, I had to scalp a few out of my old machine that I built in 73 and 74. A couple of 74 193s and some 74 75s. I don't know what the new ones are, the 74 LS, which are a little bit different than the originals. They probably got some bad ones anyway when I ordered them. So the 1101 seem to be working all right. I've got 4 memory boards for it. I've got 2K of memory on this one. I only had 1K on the original. I've got 2K on this one. I actually have 2 more boards there to put in, but I'm watching the power supply, make sure I've got enough power here. If not, I'll have to do a little work on the power supply system. But I'm running the one of the test programs that came with the original documentation here. A binary counter, which is displayed on output port 0 here. This is your address port. Kind of flashing while it's running. You can't see the flashing. This is the memory data port. And here you've got the output counter in binary as it loads up to 255 back to 0 and does it again. A replica of the switch panel. There's the original switch panel there. I haven't put labels on the new one yet, and I'm probably gonna use that as a template and do a little better, nicer looking job on that panel when I build the final enclosure. There's the original panel on a larger perf board. I just use that because it's got the legends on it as to what each switch does, although I've got them pretty well memorized now after all the testing. Here's auxiliary power out, 5 volts, if I want to power some piece of test gear or another peripheral or something with while I'm testing. So we checked our, we don't need the scope anymore. Checked our clock frequency. It's right on the button at where it should be. Crystal control clock, 500 kilohertz, and we may juice that up a little bit. We might try to speed that up later. We're going to do a lot of playing around with this baby. We're going to use an Arduino to drive the switches to create a sort of a BIOS for it rather than using a EEPROM, electrical alterable permanent read-only memory. So that should be an interesting project. I've got part of it written now to do the button pressing, but I want to do it, get to do the load and save and everything we used to would have done with a paper tape or towel type machine back in the olden times. Just got another board from Hank, my friend over in the Netherlands, who copied these boards from the originals and made a little smaller boards, but the boards are plated through. Much easier to build these boards than the originals. But it was a fun project, and during the debugging, I think the only thing I found really were the bad ICs that were in there. Once we got those corrected, we need to do a different memory bus here than this one. I had that screwed into one of the wrong ports here before. There are 2 rows on the bottom of these connectors, and I had one of them on the wrong port, wrong place, wrong set of rows, or the wrong row set of pins. So once I corrected that, why then the memory is working great. I'll write and run a little memory test program for it before I put the other 2 boards in. And over here is the original, much bigger boards. You can tell I got a couple of 74 75s out of here to put them in the original, or in the replica. So it's coming along. Over here is where we built the machine. Here are the 2 memory boards waiting to be put in. And we just got this board today from Hank. It's another output board, which will give us a total of 7 output ports rather than just the 3 ports that we have on the machine now. We intend to do quite a bit of programming in assembly language. Actually, we have to hand assemble it. I haven't been able to come across a real good assembler. I might write one, at least a partial one, to calculate addresses for me. It's a pain in the tail to do hand assembly of these programs. And if you want to change something and things shift around in memory, you got to go back and redo the whole thing. So I'll probably do something about that too. Anyway, the machine's up, the machine's running, so we'll move on to the rest of the project, or the second stage of the project, I guess you might call it. Actually, maybe there are three stages. I've got to finish up the power supply work, put it in a case. Had a good idea from Hank's Construction to use plexiglass for the case, and Dave's got the plexiglass tools to shape it and cut it down at the lab, so he'll help me out with that. I already got the base here. It's out in the garage, and I'm using the base from the original for this. You can see how much smaller it'll be. This was lengthwise on the sideways on the old base to fit those big boards and that big panel in there. Everything's maybe 3/4 size now, much smaller. And that's an advantage, actually. Original boards were huge, had a lot of real estate between the ICs on the originals. Well, there it is. It's just plugging right along. We'll let you know as we get into the next stages. Love doing this stuff. This is just a great project, even though it's a 40-year-old design, 40-year-old computer. So what? So what, I say to myself, so what? This was the Mark 8 by John Titus. It was the very, very first probably mini computer, they called it, but it's a micro actually, on the market back in Radio Electronics article from 1973. A couple of months later, the MSI 8080 came out, followed closely by the Motorola 6800 Southwest Tech Products system. Then they started popping up everywhere, Selby and a number of others, Commodore, a number of other kits, until Apple came along and said, you know, some people like to program, and they're not really into doing the electronics, and have the electronics knowledge and construction knowledge to build their own machine. So him and a fellow named Paul Allen, I guess, they went out in the garage and they built this Apple computer based then on a 6802. And I believe that was the CPU, the Motorola CPU, which was in competition with the Intel series. And they built one, they put it together, and they sold it. Now, wow, those fools. There's really no future in that. Who wants a little bitty computer like this that is so limited when you can build one a heck of a lot more powerful? But nope, they did it. And the rest is history when it comes to Apple. So this goes back before Apple, let me tell you. I just got the lunch call, so I'm off to lunch. All right, that's it anyway. Out and over. On to the next phase.